the stuff? Do y'all remember? Grouping. We used factoring by grouping. What else did we do? We did the swapping, the substituting a variable. Y'all remember doing that? Are y'all so quiet because you don't want anyone to hear you? Is that the deal? Like when I push record, y'all just shut down? Is that? No? It's fine. It really is. Y'all are so awkward, but it's fine. All right, so today, 2.6 part 3. We're still doing other types of equations. Today, when is our test? Not yet. I will let you know when it is. It'll be a million years from now. We're not ready. Today we're doing a type of equation called a radical equation. Radical equations. Okay? That's going to be any equation that has a radical sign in it. So if I have this looking thing, that's called a radical. If I have that and I have some mumble jumble under here, equals something else on the other side. That's a radical equation. And we're going to look today at how do we solve those. Okay? So a couple of how to solve these kinds of equations, radical equations. Number one, we're going to isolate the radical. Bless you. Isolate the radical. That means get all of the stuff that's with it on the other side of the equation. Isolate the radical. Okay. Then we want to get rid of the radical sign. To eliminate the radical, so eliminate the radical by raising both sides of the equation, both sides, to the nth power. Raising both sides to the nth power. Okay. Now, why does that work? I need you to remember that I might have the nth root, where n is the little number in the index. Do y'all remember that? So it's not always the square root. It's the square root if I don't see a little 2 up in there. Okay? It's any other root if there's any other number. So if it's the cubed root, you'll see a 3. So to get rid of the cubed root, we're going to raise it to the third power. So to get rid of the nth root, we're going to raise it to the nth power. Does that make sense? So that's why I left it open-ended as raise both sides to the nth power. It just depends on what's in the index of the radical. Okay. The reason that works, why do I get to raise it to the nth power? If you'll remember, if I have a number x to the 1 over n, like if I have it to the half power, that's the same thing as taking the square root. If I have it to the third power, that's the cubed root. So if I want to get rid of that power, I raise it to the reciprocal power, right? That's why this is the move. Once we've done that, number 3 is going to be solve the remaining equation. Solve the remaining equation. Solve the remaining equation. Number 4, check for extraneous, this is a new word, check for extraneous solutions. Extraneous solutions. So that means we're going to plug our number that we think is our answer back into the problem, and we're just going to see whether or not it works in the problem. So check for extraneous solutions. We're going to plug that number back in. On your calculator, it's either going to read true or false, right? If your answer actually works, it's true, that number's good. If your answer doesn't work when you plug it in on the calculator, then that'll be an extraneous solution, one that doesn't work. Good? Everybody okay so far? Everybody's breathing? No need for resuscitation, anything like that? Okay. All right. So here is our first problem. This is example 6. If you'll remember, yesterday we skipped examples 6, 7, and 8. And I told you it would make more sense later to do them later. All right, so our problem here says solve the square root of 15 minus 2x equals x. Our problem says the square root of 15 minus 2x is equal to x. Okay. And so step 1, this is obviously a radical equation. It's got a radical in the problem. Step 1 says isolate the radical. That means if there were any numbers over here before or after the radical, we would want to add or subtract them. Okay, we would want to get it by itself. In this particular problem, we don't have any of that. The radical's already isolated. Okay, so yeah, read to me. Step 2 says raise both sides to the nth power. Judson says square it. Why square it? Because it's the square root of 15 minus 2x. Okay. What happens when I square a square root? It cancels. It goes away. So what's left on that left side? Sure. 15 minus 2x equal to x squared. Okay, life is good. No problems here. What kind of equation does this look like now? You get 2 points if you know what kind of equation this is. One we've done before. It has a squared term. It's quadratic. You can get 2 points. I don't know 2 points for what, but you get them. They're yours. It's quadratic. It has an x squared term. That means if we could put it in the form of ax squared plus bx plus c, we could solve. If we had something like this equals 0, we could solve it. We have methods for solving. We can factor. We can complete the square. Some of us can sing a song. Okay, we've got options here. So right now, we want to set it equal to 0. I think it's always best to have a positive x squared term. Always best to have positive x squared. So wherever x squared is positive, that's where he's going to get to stay. And I'm going to move everything else over to that side. Okay? So right now I'm going to add 2x to both sides and subtract 15 from both sides. Okay, so we have 0 equals x squared plus 2x minus 15. That may drive some of you crazy. You may prefer x squared plus 2x minus 15 equals 0. They're the same. They're the same. Okay. So now I don't see a coefficient of x squared. There's nothing in front of the x squared term right here. Since that's the case, I just get to factor it. What are factors of negative 15 that might make 2? 5 and negative 3. So x plus 5 and x minus 3 equals 0. Y'all remember when factoring was the hardest thing we've done ever? Those were the days. So set both pieces equal to 0. X equals negative 5 and positive 3. Okay. We think these are our answer choices. We're going to check it in the calculator. Okay, I'm going to pause right here and I'm going to show you how to do that. Okay, so once you check your solutions on your calculator, that's as far as I need you to go. All right, you can use your calculator. You don't have to plug in by hand. To do that checking in the classroom, because your calculators don't get to go home with you, so you don't have any way of doing that, what I want you to do for your homework tomorrow, I want you to do as much as you can on paper, leave your solutions, and then when you get in here tomorrow, check them. And you can tell which ones work and which ones don't. Okay? All right, so here's a try it. This is the try it that goes with example 6. It's a little different than the problem that we just worked. So we have the square root of x plus 3 equal to, and on the far right side, 3x minus 1. So we're still going to do the same thing. We're still going to isolate the radical. Is it already isolated? Yes. Okay, so now we want to raise both sides to the nth power. In this case, the n would be 2, because we don't see a little number in the index. So we're going to square both sides. We're squaring both sides, which means everything on the right side. So I put parentheses and raised it to the squared power. Okay? Now I need you to remember, back when we first started dealing with these kinds of things, a binomial squared, I don't get to just say, hey, a plus b is a squared plus b squared, right? I don't get to distribute the exponent. That's not a thing, all right? I really tried to caution you against that when we first started doing this. Instead, what actually happens? When I square something, what am I doing? He's saying expand it. I'm multiplying the whole binomial by itself. So I've got to FOIL it out. Okay, I don't just get to go in there and distribute that cute little power and call it a day. So we're going to have 3x times 3x. What's that going to make? 9x squared. And then a 3x times a negative 1. Minus 3x. And then a negative 1 times a 3x, which is going to make minus another 3x. So what happens in the middle is I have a double product. I have two 3x's. So instead I'm going to have minus 6x in the middle. Minus 6x in the middle. And then on the end, negative 1 times 1? Plus 1. That handles the right side. What happened to the left side? X plus 3. We like the left side. That right side can go away. Now what? Sure, subtract 3. Set it equal to 0. Subtract x. So 0 is equal to 9x squared minus, what's 6 minus 1? Minus 7x. We're digging a deeper hole. Minus 2. Good. Everybody okay? Still breathing? Now, I do have a coefficient of x squared. So what's my move this time? Yeah. First, I would look for a GCF, but I don't see one. So 9 times negative 2 makes negative 18. We need factors of negative 18 that make negative 7.
Negative 9 and 2.
Good. Negative 9 and positive 2. So we're going to bust this into 4 terms so that we can use grouping. 9x squared minus 9x plus 2x minus 2. Yeah? Then we can use our parentheses, or on the first 2 terms and the last 2 terms. What next? Factor out a GCF. What's the GCF on the first group? 9x. Leaving me x. Good. X minus 1. And on the second group? 2. Leaving. Good. So 0 is equal to 9x plus 2 and x minus 1. So now what? Set each piece equal to 0. 9x plus 2 equals 0. Solve for x. 9x is negative 2. Divide by 9. X is negative 2/9. And 1. Okay. Check them. Check them on your calculator. All right, so we're going to start example 7 now. Hopefully you've checked on your calculator. We got on the last one that, was it 3? Negative 2/9 and 1. 1 works, negative 2/9 did not work. Okay. All right, so here comes example 7. Okay. We have the square root of 2x plus 3 plus the square root of x minus 2 equals 4. And now we have a situation where we have two radicals in one problem. Okay, everybody look at me. Look right here. You can do hard things, okay? This is not hard. This is going to take a long process. It's not hard. There's nothing tricky about this at all. It's just that it takes a long time, okay? But you can do it. You got this. Your inclination is probably going to be to try to square both sides and get rid of the radical. But what we talked about just a second ago is when I square something, I'm not able to distribute that power to both pieces. Okay, that's not how it works. So that's not a move we get to make here. Okay, our move instead is going to be isolate one of the radicals. I don't know which one you want to isolate. Doesn't matter. Pick one and isolate it. So for right now, I'm going to focus on isolating the first one, meaning I'm going to move everything else to the other side. So on the right side, I have 4 minus the square root of x minus 2 equal to the square root of 2x plus 3. Okay? Now we're going to square it because I've isolated one of the radicals. It's the best I can do at this moment. So we're going to square both sides and we can get rid of at least one of them. Okay. So on the left side, when I square the square root, I'm left with 2x plus 3. On the right side, I've created this situation where I have a binomial. So I'm going to change colors up here. 4 minus the square root of x minus 2 times itself. 4 minus the square root of x minus 2. Right? So we're going to FOIL this one out. The first piece, I'm going to have 4 by 4. That makes 16. And then I'm going to have 4 times negative square root x minus 2. And hold on, don't write it yet. You're going to get another one of those. 4 times negative square root x minus 2. So if I got 2 that are both negative 4, then how does that work out? Makes negative 8. Okay, so what I'm saying is I'm going to have a negative 4 square root x minus 2 and another negative 4 square root x minus 2. And so we can group those together right off the bat, and we can say 16 minus 8 square root x minus 2. Okay, that's the perfect square binomial thing. When I square it, I get a double product in the middle. What's on the end? A negative times a negative makes a positive, and a square root x minus 2 times a square root x minus 2 makes, when I square root and I multiply them together, I'm left with the argument. Right? Square root 3 times square root 3 is 3. Square root x minus 2 times the square root of x minus 2 is x minus 2. That's all that's left out of that piece. Okay, so we FOILed this out. 16, we FOILed out 4 minus the square root of x minus 2. And what we got was 16 minus 8 square root x minus 2 plus x minus 2. Believe it or not, this is better. This is better than how we started. Now what could we do? Isolate the radical. Yes, ma'am. Isolate the radical. So we're going to whittle it down to where we have only one radical on the one side. So what could we do? We could subtract 16 from both sides. Last. In a little while, we might divide by 8. So I got 2x. 3 minus 16 makes negative 13 equals negative 8 square root x minus 2 plus x minus 2. Now what? minus the x from both sides, so subtract the x, and add the 2. So 2x minus 1x makes me have x, negative 13 plus 2, negative 11, equal to negative 8 square root x minus 2. Yeah? Okay. Now, we do have a rule for squaring a product. If I square a times b, then that becomes a squared times b squared. That does work. If it's a product, we do get to give both pieces the power. If it's a binomial, we don't. Okay? But because this negative 8 times the square root of x minus 2 is a product, we get to square it. So we're going to square both sides. Right? So that's going to be a positive 64. And what happens when I square the square root? It goes away. That's why we're doing this. So we just have 64 times x minus 2. Deep breath. Let's talk about that other side. X minus 11 group squared. How's that come out? It's going to be x squared. Right? So we've got an x minus 11 times itself. We're going to get an x squared. I'm going to get a negative 11 and another negative 11. That's a double product. So what does that make? Negative 22. So that's my middle term, negative 22x. And my last term, negative times a negative, is a positive 121. Good. Y'all still trucking? Yep. Distribute that 64. So we've got 64x minus 2 by 64 is 128, equal to the trinomial on the left side. Now what? Set it equal to 0. So we're going to move the 64x to the right, to the left. And we're going to add the 128. Okay. So I have x squared minus 86x plus 249 equals 0. So we need factors of positive 249 that make negative 86. I think I struck gold the other day because I just tried a 3. Just right off the bat, I decided to divide it by 3, and it worked. So my factors were negative 3 and negative 83. I'll save you a lot of heartache right there. I don't know. It was the first number I tried, and it worked. So when we stretch that out, when we factor that, then we're going to have an x minus 83 and an x minus 3 equal to 0. So our answers are x equals 83 and, goodness gracious sakes alive. Yeah, you can check it. While you're checking them, I'm going to go ahead and put your try it problem up here. So if you want to get started on the try it, you can. This is the last thing that we're going to do today. So we've got 10 minutes. Maybe in 10 minutes we can get one problem done. We'll see. Anybody check those answers on the last one? What worked? 3 was good, 83 was extraneous. Is that right? 3 works, 83 is extraneous. Extraneous. On your test, I would just put an X through the one that doesn't work. On your test, you can mark it. X means extraneous. This one, no good. All right, so here's your problem. Do y'all want me to talk you through it, or do you want to get after it yourself and I just work it on, I'll work it and you work it? You don't want me to work it at all. You want me to do it with you? Yes. Okay. So the first thing we're going to do then is we're going to isolate the radical. I would isolate the first one, and I would swing the second one to the other side. If I work it with you, we have to hustle because we have 8 minutes left. So I have now the square root of 3x plus 7 equal to 1 minus the square root of x plus 2. Okay. Again, this is not hard. It's just forever long. So what do we want to do now that we've isolated one of the radicals? Square both sides. Get rid of what you can get rid of. So when we do that, on the far left, what do I have left? Right, 3x plus 7. On the right, I have a binomial situation, which when I expand that, is going to be 1 minus the square root of x plus 2 times itself. 1 minus the square root of x plus 2. So I'm going to square the first. That's going to be 1 times 1 is 1. I'm going to double the product in the middle. What's the product in the middle? That would be 1 times the negative square root of x plus 2, which would be negative 1 square root x plus 2. If I double that, how does that come out? Minus 2. In other words, if I've lost you right there, we're going to have minus 1 square root x plus 2 minus another 1 square root x plus 2. What I'm saying is that's minus 2 square root x plus 2. It's a double product in the middle. And then you square the last, which when I square root x plus 2 times itself, what do I get? X plus 2. And that's it. The negative times the negative is a positive. So all of this blue business that I just got from squaring this right side becomes 1 minus 2 square root x plus 2 plus x plus 2. My 6th period, that's where I lost you guys right there, was in getting that middle term to be a negative 2. Okay, 7th period, y'all seem okay with that. Now what? Isolate the radical. So maybe subtract that 1 right there that's in the front. 3x plus 6 equal to the negative 2 times x plus 2 plus x plus 2 minus x minus 2. Get both of those over yonder. I don't know if they say yonder in the real world. 3x minus x makes how much? 2x plus 6 minus 2, 4, equal to negative 2 square root x plus 2. Okay, now what? Square both sides. Because now I've isolated the other radical, right? So when I square this business, this 2x plus 4, I multiply it times itself. So 2x plus 4 times 2x plus 4. I'm going to square the first. 2x times 2x is 4x squared. In the middle, I'm going to have a 2x times a 4, which makes 8x, and I'm going to get another one of those. So I've got plus 8x plus 8x. In other words, 16x in the middle. And then on the end, square the last. So on the right side, or the far left side, I have 4x squared plus 16x plus 16 equal to, I'm going to square this thingy over here. Negative 2 squared is 4. The square root of x plus 2 squared, x plus 2. Set it equal to 0. So you've got 4x squared plus 16x plus 16 equals, you could play some hippity-hoppity distributive property right here, 4x and 8. Right? Subtract those from the left. So 4x squared plus 16 minus 4, 12x, and 16 minus 8, 8. So I've got 4x squared plus 12x plus 8 equals 0. 4x squared plus 12x plus 8 equals 0. How do we want to factor that? Anybody feeling like pulling a GCF? Are they all divisible by 4? I would. That way you can kill it. So 4x, pull the 4, you've got x squared plus 3x plus 2 equal to 0. That way you can divide both sides by the 4 and you're gone. That guy's out of the way. So x squared plus 3x plus 2 is 0. Now what? Factors of 2 that make 3? There's no coefficient of x squared, so you just get to say factors of c that make b. Factors of 2 that make 3. 1 and 2. Whew, thank goodness for prime numbers. X plus 2 and x plus 1. So what are my answers here? X equals negative 2. X equals negative 1. Don't get all the way to here and forget to set your numbers equal to 0. Don't get there. Okay, set them equal to 0. Solve for x. And then somebody check it for us. Goodness gracious. Somebody type that thing in and let us know what's extraneous. Sorry. Negative 2 works. Negative 1 does not work. Thank you, thank you, thank you. All right, that's a wrap.